Welcome back. So we're going to pick up with simplifying radicals. This is a really important skill in Unit 5 as we see a lot of radicals and they're nothing to freak out about. We just need to know how to simplify them. So there's 3 rules for remembering how to simplify radicals. And that first rule is that you can have no perfect squares under the radical. So no perfect squares under the radical. An example of that would be if you had the square root of 100. Well, you wouldn't say the square root of 100. The square root of 100 is 10. Or if you had the square root of 200, well, 100 is in 200 and 100 is a perfect square, 10 times 10. You can't have that. So then that would be 10 root 2. You can't have perfect squares under the radical. And if you remember our perfect squares, it would be 1 times 1 is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 49. It's just the number times itself. So that's our first rule with simplifying radicals. Our second rule is that you can't have any fractions under the radical. So no fractions are allowed under the radical. So, like we're not allowed to have 100 or 200, you wouldn't be allowed to have something that's like the square root of 1/3. That's a fraction that's not allowed. Or like the square root of 2/5. That's a fraction that's not allowed. And kind of with that rule is that you can't have any radicals in the denominator of a fraction. So, you can't have fractions under the radical, and you can't have radicals in your denominator. So, no radicals in the denominator. Now, this is where it gets a little bit tricky for people because if you can't have radicals in the denominator, what would not be allowed would be 2 over root 7. That's not allowed because I have a radical in the denominator. That I would have to simplify. I'd have to take care of it. But I could have radical 7 over 2. That would be allowed. There's not a fraction underneath the radical. It's only 7 and it's not in the denominator, so that would be okay. We can have radicals in the top of fractions, but not in the bottom. So let's take a look on how to go through this. So a perfect square, I like to think of it as a perfect pair. So 10 squared is 10 times 10. 25 is 5 times 5. 16 is 4 times 4. 49 is 7 times 7. And if you can't have any perfect squares under the radical, you can't have any perfect pairs. So I'm going to take a look at this radical, square root of 160, and I'm going to try to break it down, and I'm going to see if I have any pairs. So I'm multiplying. Ask yourself, what would multiply to give you 160? And there's lots of options, and this is where, however you start, it doesn't matter because we're all going to end up in the same place. When I see the square root of 160, I think 16 and 10. Maybe you don't think 16 and 10. Maybe you think 8 and 20. So let's go with 8 and 20. Okay, now the question is, does 8 break down? Is there something times something that would give me 8? Well, that's 4 times 2. So I'm going to break 8 down into 4 times 2. Well, 2, I can't break. 2 would just be 2 and 1. So I'm not going to break that down any farther. But 4 can break down into 2 times 2. So I broke the 8 down into 2 times 2 times 2. And now I'm going to go over to 20. So 20 would break down into 10 times 2. 2 I can't break down, but 10 could break down into 5 and 2. And so that 20 broke down into 5, 2, 2. Now, keep in mind, if you had done 20 as 4 and 5, then the 4 would have broken down into 2 and 2, and I still would end up with 2, 2, 5, 5, 2, 2, same thing. I'm just looking for these numbers down here at the bottom. So now I'm going to look at all these small numbers that I broke down into, and I'm going to look for pairs. Remember, there's 2 in a pair. So it doesn't matter where they are. That's a pair, so that can count as a pair. That can count as a pair. So I have a pair of 2's there. I could use that pair of 2's. And then I'm going to look for my solo numbers. And my solo numbers here would be this solo 2 and this solo 5. I say solo because they don't have a pair. They have nothing to pair up with. So to simplify this radical, I can't have perfect squares. I need to take my perfect pairs out. And only one per pair can come out. This is where it gets confusing. Is I broke it down, right, into all my little numbers. I looked for pairs. And what can come out is one per pair. So while I have 2 pairs of 2, I can't take out 2 and 2 and 2 and 2. I can only take out 1 per pair. So I'm going to take out 2 and 2. So if I take out 2 and 2, 1 per pair, 2 times 2 would be 4. That can come out because I took out 1, 2 per pair. Square root, well, what's left over? What are our solo numbers? 2 and 5. 2 times 5 is 10. That stays under the radical in the house. And that's how I simplify a radical. Now, we're going to do some more. So if you're freaking out, don't worry. We're going to keep on going. Let's take a look at the next one, the square root of 72. So ask yourself, what times what would give you the square root of 72? And that'd be 8 times 9. Or maybe you come up with another number, 36 and 2. It doesn't matter. Just start wherever you want to start. So I'm going to start with 8 and 9. I know that 8 can break down into 4 and 2. And I know that 4 can break down into 2 and 2. So essentially, I'm just making a factor tree right now. That's all I'm doing is just making a factor tree. Okay? Now 9 would break down into 3 and 3. And I can't break these numbers down anymore. So I'm looking here at all these 2s, all these 3s. So now you're going to ask yourself the question, do you have any pairs? So I see a pair of 3s. Do I have a pair of 2s? Yeah. And I have 3 2s, which means I have 1 pair and 1 solo. Okay, 1 per pair can come out, which means I'm not going to take out 3 and 3 and 2 and 2. It's 1 per pair. So I can take out 1 3 and 1 2. And when I take them out, I multiply them. So 3 times 2 would be 6, and that can come out of the radical. What's the solo number that has to stay underneath? 1 solo 2. So when I simplify that radical, it would be 6 root 2. And this process is me taking out the perfect pairs. I'm taking out the perfect squares under the radical because I can't have any of them. Now we can do this same exact thing with variables. If you have the square root of x to the 6, x to the 6 would be x times x. Remember, it's all times itself times x times x times x times x. And then if I look for pairs, there's 1 pair, 2 pair, 3 pair. So what's really nice about this problem is that everything gets to come out of the house. Everything gets to come out of the radical. Remember, only the solo numbers stay underneath, and there's nothing solo about this. So if I have 3 and I take out 1 per each one, that would be x to the power of 3 because I'm multiplying. Not 3x, that'd be x to the power of 3. That's it. So if I take a look at x to the 5th, let's do that same process again. X to the 5th would be x times x times x times x times x. Ask yourself, how many pairs do you have? And remember that that pair is going to become your exponent when it moves out of the house. So if I have 2 pairs of x, I'm not going to say 2x, I'm going to say x to the power of 2, and that would be out of the house because it was pairs. Well, I have a solo x, he can't come out, so he's just going to stay underneath the radical, and then that's it. That's your answer. So stepping this up, we're going to look at this one. If I have the square root of 54 into the 7th. So let's start by breaking down 54, and then we'll deal with into the 7th. 54 is going to be 6 times 9. And maybe you thought of another number. Once again, it doesn't matter. We all have to break it down. We all end up at the same place anyways. So 6 would break down into 2 and 3. And 9 would break down into 3 and 3. So I broke my numbers down. Now I'm looking at these, asking myself, do I have any pairs? And I do. I have a pair of 3s, and that's it. Which means 1 3 can come out. So I'm going to go ahead and put that 3 out. 2 and 3 would have to stay in. So 2 times 3 would be 6. That stays in. And I'm multiplying. Okay, I'm not done though yet. I dealt with the 54. The 54 was the 3 came out per pair. 6 stayed underneath. Now I need to deal with into the 7th. Now, into the 7th would be 7 of them. So that'd be 1, 2, 3, 4, 5, 6, 7. And as I can see, I have 3 pairs. So whenever it comes out, that's my exponent. So if I have 3 pairs, that would be n to the third on the outside. And then that solo n is going to stay underneath with the 2 and the 3 that didn't have any pairs. And that's it. That's how we simplify these. So looking at some harder ones. If we can do these hard ones today, then you can do the easier ones later on this week. So 80 would break down into 8 and 10. And for now, I'm just going to ignore this letter over here. I'm going to look at the 8 and the 10. 8 can break down into 4 and 2. And then 4 would break down into 2 and 2. So that 8 broke down into 2, 2, 2. Now I'm going to look at the 10. So I'm breaking down each number. So I broke down the 8. Now I'm going to break down the 2. Or the 10, my bad. So 10 would break down into 5 and 2. 5 would break down to 5 and 1. That doesn't help me. 2 is 2 and 1. So once I've broken it down as far as I can, now I'm going to look for pairs. So I see a pair of 2s right there. I see a pair of 2s right there. It doesn't matter if they have some distance between them. So what can come out would be 2 and 2, 1 per pair. 2 times 2 is 4. What stays in would be the solo 5. And now I'm going to look at m to the 9th. Well, m to the 9th would be 9m's, so it's going to be a lot. So that'd be 1, 2, 3, 4, 5, 6, 7, 8, 9. How many pairs were there? There's 4. So when I take it out, that becomes my exponent. So m to the 4th would be the exponent, and then that solo m would stay underneath. Now, what made this problem different was this negative m out front. All I'm going to do is I'm going to look at what should be outside and what should be outside, and the outside parts can go together. So instead of a positive 4, that negative is going to change it to a negative 4. I'm going to add an m in there. So if I have m to the 4th, well, if I put another m in there, that'd be m to the 5th. And then what's under the house is guarded and is going to stay under the house and go untouched. That's square root 5m. And that's how we would simplify this radical. That was a much harder one, y'all. Some of these, like I said, are going to be a lot harder than the ones you're going to see at all as we continue to go through this unit. Okay, so let's take a look at this one over here. And if I asked you what's wrong with this, it goes back to this. Look at statement 2. We can't have any fractions under the radical. So I have the square root of 64 over 49. So let's think for a second. If I were going to rewrite this, so let's change this. Let's change this to be the square root of 64 and the square root of 49. That's a legal move. They both had a square root over them, so I'm just going to change it to be a square root on the top and a square root on the bottom. Well, ask yourself, do you know what the square root of 64 is? What times what would give you 64? Think about it. The square root of 64 is 8, right? It was 1, 4, 9, 16, 25, 36, 49, 64. So the square root of 64 is 8. And if I ask you what's the square root of 49, well, we just did it. What times what would give you 49? That's 7. And then that's it in that case. Is there any radical here to worry about? No. So I show you this example because sometimes we get real simple ones where it's just like, I'll have students be like the square root of 100. Just remember the square root of 100 is 10. That's it. Okay, now let's take a look at this one. I have the square root of 3 over 7. I'm going to rewrite it as the square root of 3 over the square root of 7. Okay, now remember, you can have a radical in the top. The square root of 3 is not my problem here. What happens is I'm not allowed to have a radical in the denominator. It's the square root of 7 that's my problem. So what I really like about radicals in the denominator is that radicals in the denominator have a quick fix. And I'm going to show you that quick fix right now. Whatever you see in the denominator, if you have a square root, I'm going to multiply it by the same square root and they cancel out. So here's what I mean when I say that. If I have a square root of 7 on the bottom, I'm going to multiply by the square root of 7 to cancel it out. Because the square root of 7 times the square root of 7 would be the square root of 7 times 7 is 49, and the square root of 49 is just 7. So if you have a radical in the denominator, just multiply it by itself to cancel it out, and it just becomes a 7. Now, This is where I got to be careful, because if I multiplied the bottom, the denominator by the square root of 7, I need to multiply the top by the square root of 7 to balance it out. So what's the square root of 3 times the square root of 7? Well, 3 times 7 is 21, so it would be the square root of 21 over 7, and that's your answer. Now, it's kind of an ugly answer. Like, let's just be honest, it's kind of weird looking, but that's okay. I'm allowed to have that. I can have a radical on the top, just not in the bottom. Now, what you're not to do is to go, oh, 21 divided by 7 is 3. Because it's not that. That's not the answer. Because it's not 21. It's the square root of 21 over 7. There's a difference there. Okay. Now, we're going to change out these really hard ones. I want to cross these out because let's take a look at some much easier ones, because you're not going to see, we're doing the hard ones today. The ones you're going to see later on are much easier. Let's take a look at the square root of 5 over 11. And then let's take a look at let's do 2 over the square root of 3. So, let's change those problems up a bit. So my first step, if I have the square root of 5 over 11, I'm going to rewrite it as the square root of 5 over the square root of 11. Okay, now ask yourself, what's causing us trouble here? What's our problem? Is it the square root of 5 on the top, or is it the square root of 11 on the bottom? And if you said the square root of 11, you're right. So here's how I'm going to fix it. I'm just going to multiply it by the square root of 11 on the bottom and on the top. So my denominator would become the square root of 11 times the square root of 11 is just 11. It cancels out when I multiply it by itself. And then my numerator would be 5 times 11, which is the square root of 55. And then that's it. You're allowed to keep your answer just like that. Okay, keeping in mind, it would not be 5. It's not 55 divided by 11. It's the square root of 55 divided by 11. So most of our answers, we're going to have a radical in there, and you're just going to keep that radical in there. And to take a look at our last one, I just have a normal 2 on top. Not much to do with that, but I do see the square root of 3 on the bottom. So ask yourself, what's causing us trouble here? And if you said the square root of 3, you're right. So I'm going to multiply by what to get rid of it? Well, just multiply it by itself on the bottom and on the top. So the square root of 3 times the square root of 3 is just going to become 3. That's easy enough. And I need to be careful with the numerator, because 2 times root 3 wouldn't be root 6. The 2's out. It needs to stay out, and the root 3's in. It needs to stay in. So the numerator would be 2 root 3 over 3. And that's it. I know it's a weird looking answer, but that is our answer. So hopefully you were able to take some takeaways from simplifying radicals. This is a really big skill as we move and we look at special right triangles with those radicals, and we look at Pythagorean theorem with those squares and those square roots. And that's a big part of Unit 5 is, can you simplify radicals, and can you know what these words mean? Now, another part of Unit 5 that people tend to hate is word problems. But what's really nice about all of these word problems is that they're all going to be triangles. We're in a triangles unit, so every word problem is going to be a triangle. So let's take a look at a few, and you're just going to see that they're really not as difficult as you might thought that they would have been. Okay, number 1 says that Lisa drives her car 46 kilometers south and then 13 kilometers east. How far is she from her starting point? Now, I don't care about the question. I'm not solving this today. We're not that into Unit 5 yet, but the real question is, could you draw a picture of this? Well, if Lisa drives her car 46 kilometers south would be down. Maybe you remember never eat soggy waffles, so that would be 46 kilometers south, that's down. And then she goes 13 kilometers east. So if you remember, like, never eat soggy waffles, east is to the right. So now she goes 46 kilometers south down, and then she goes 13 kilometers east. That's to the right. What shape are we making here? We're making a right triangle. That's because most of this unit is going to be all about right triangles. So how far is she from the starting point? There's your X. Now, we don't spend a ton of time on word problems because most of you can figure these out on your own. You can do really well with this, okay? Let's look at the next one. Town A is 90 miles from, not from, it should be from town B and 18 miles from town C. Town A, B, and C are forming a right triangle at A. A road connects towns B and C directly. Find the length of this road. Okay, here's our big clue. They said it was a right triangle, so I'm just going to sketch out a right triangle. Most of these are going to be triangles. So if you can sketch out these pictures and then you are somewhat decent at the simplifying radicals, everything else in this unit is just a formula and you'll be smooth sailing. These are just 2 skills from prior years that you need to have. So it said that the right triangle is at A, so I'm going to do A, B, C, just like that. Okay, town A is 90 miles from town B. And it says it's 18 miles from town C. Okay, think about this. Hypotenuse cannot be 18. It can't be smaller than 90 because the hypotenuse is supposed to be your longest side. What they're saying is that town A is 18 miles from town C. And then it said find the length of the road that connects B and C. There's your X. That's it. So if you can simplify radicals and you can sketch out pictures that match the word problems that you're going to see in this unit, after that, everything's just going to be a formula and smooth sailing. So for your practice today, you're going to have some word problems that you're going to have to draw. You're going to have some pictures where you just have to figure out hypotenuse, adjacent, and opposite. And if you have those skills plus some radical skills, you're going to be doing great in Unit 5.